In today's math lesson, we're going to graph quadratic functions that were given to us in vertex form. We remember from the previous lesson that vertex form is f of x equals a times the quantity of x minus h that is squared plus k. Graphing quadratics from the vertex form can be done in 3 easy steps. Let's find out what they are. The first step is to plot your vertex, and your vertex comes from h and k. Remembering that h will be opposite the sign that is in the quantity squared, while k is the exact sign that is what is showing in your equation. The second step is just to determine the direction that your quadratic is going to open. Remembering this is dependent on a. So if a is positive, then we open upward. But if a is negative, then we open downward. The third step is a little bit of a trick, kind of like a hack, I guess. If you treat a very much like a slope with rise over run, from the vertex, you can get your first set of points very quickly. Now, you cannot use a like a slope after that first set of points. That won't work. You'll either have to work the numbers through a table in your function of your equation or use something like Desmos to help build a table. Here in example 1, we see that we have a function of 4x squared. There's no h and no k showing in this particular function. So easily stated, what is the number for no? Oh, well, nothing, which is the number 0. So from there, now that I have my h and k showing in the expanded form of this vertex form of the function, I can go find what I need to graph it. So from here, I can say, oh yeah, my vertex, which is h and k, will be 0, 0. No need to worry about positive or negative h in this particular problem. And there it is. There's my vertex right there. Now we need to discuss a in order to do parts 2 and 3 to graph your function. The first thing we notice is that our 4, our a, is a positive number, which means that our quadratic will be opening upward. So it's going to look like a smiley U. Our third step shows that a is going to be 4 over 1 because whenever you have a slope and you need a fraction, you always can put 1 underneath an integer. So going out from my vertex, we would move upward 1, 2, 3, 4 units and out to the right 1 and also out to the left 1. This is very different from linears where you only moved in one direction. But here, because of the symmetry that is shown very, very nicely with our quadratics, we can see, we had to move to the right and the left. Here is your beautiful quadratic. And finally, a great way to check your answer is to again use Desmos. So if we graph our original function in the problem on Desmos, we will see what we are supposed to have created by hand here on the paper, and it matches very nicely. This is a great way just to check to make sure that you know what to do and how to do, and that you're doing it correctly. Here in example 2, we are given the function negative 7x squared. And again, I don't have an h or a k to contend with. So when they're not there, let's go ahead and fill it out with some zeros. From my filled out function, I know that my vertex of h and k will again be 0, 0. And because h is 0, I don't have to worry about a positive or negative movement. And there it is plotted onto my paper. Now let's look at a. A in this particular problem is negative 7. Since a is negative, we know that it is going to be a quadratic that opens downward. Again, treating a kind of in a hack, similar to a slope with rise over run. And since a is an integer, we know we can put it over 1 to create a fraction. We know that we are going to move downward 7 units and then out 1 unit. Where do we do this from? From our vertex. So our vertex currently is at 0, 0, and we move down 7 units and out to the right 1, out to the left 1, and now we can connect our points and make our beautifully symmetric quadratic right there. I cannot express enough how helpful Desmos is to see if you have graphed your equations correctly. So if you graph this in Desmos, negative 7x squared, you will see that it matches what we have created here. If it doesn't match, then things need to be fixed. In problem 3, we see that, hey, in addition to an a value, we also have a k value. So let's finish fleshing out this entire function so that we can see all of its parts, as we are missing the h. There we are. So from our fleshed out equation, we can see that our vertex comes from 0, negative 10, as the k value uses the sign that we are given, and h, which would change, is still a 0, so it's not an issue. So our vertex is located all the way down here at negative 10 at the bottom of our graph. Now let's examine our a value. Since our a value is a positive 3, we know that our quadratic is going to open upwards. And again, using a, very similar to slope as a hack, we see from the vertex that we are going to move up 3 units and out to both the right and the left in order to build our beautifully symmetric quadratic curve. Remembering that it is always a good choice to go and check your answer on Desmos. In example 4, we again see 2 numbers in our quadratic function, so I am still missing my h value, which means that it is still 0 in this particular problem. So we can quickly get our vertex as being the coordinate point 0, 9, easily plotted on our coordinate plane. Now let's examine our a value of negative 8. Since our a value is a negative number, we know that our quadratic is going to open downward. Now we're ready to plot our curve. So from the vertex, we are going to move downward 8 units and plot points to both the right and the left of our vertex. Again, connecting our dots in a beautiful smooth curve here on your coordinate plane. In our 5th and final example, we again only have 2 numbers, but this time we see that the missing value is our k value. So k is going to be 0. As we've discussed previously, h is always going to be used with the opposite sign than what's in the equation. Since this is a -1 in the equation, that means my vertex will actually occur at positive 1, 0, and that is located right here. Now let's examine a. Since a is 8, it is a positive number, and therefore we know that the quadratic is going to open upward. Using our hack of treating a very much like a slope, from the vertex we are going to move up 8 units and out to both the right and the left 1 unit, so that we can then connect our points and see where our quadratic travels. And as always, yes, use Desmos to help you check that you have worked through these equations correctly.